to the time limitation, and there were some issues. So, so we had a meeting with the dean and all other lecturers. Okay, but we make sure that nobody used Excel. Those the students who used Excel. So we got maybe very few, maybe 5 or 6 students. So, but we already understand. So we will take the steps regarding that. Okay, and if you feel that the question is too hard or the time was too short, so we try to manage those things by considering the deliverability. Okay, it means you will be given when we will number your paper, we will be more relaxed. Okay, so don't worry on that. And I'm not checking the question 1 and 2. I'm checking the question 3 only. Okay, and so far, what I've got right, most of you still getting good marks above 10. Okay. By this time, I just want to share the quiz marks. Okay, just hold on. I can share a few things because now it's getting difficult, like to share the things. Sometimes I forget. Later, I just scroll down and you will get your marks. Just 1 minute. This one is still check. I hope this one. Okay, so this is section 3. So this is the marks. Okay, this is the converted marks because it should be out of 2.5. So I hope if you just have a glance, this is section 3. So some have problem, but he already recover here. It's already good. This one haven't converted. Okay, I will do it later on. I think so far is okay for all of you. But few students, you already know that I don't know why it's 0. This one is still 0. Quiz 1, maybe he was not able to attend. It's okay, but he performed here. Okay. Enam, you perform only 1. This one is blank. So this one I will finalize later on. This is roughly okay. So maybe I will disclose the marks later on again. And how about the others? Section 4. Section 4 still okay. Maybe some students like this, but he recover here. So you will have the chance maybe 2 or 3 more quizzes for the second half. Okay, I think should be okay. So though if you cannot perform here, maybe you can perform in other quizzes. So here you cannot perform properly, but you perform here. But so there will be more chances. Okay. So when I will finalize the mark, I will try to share the marks again with you later on. Okay. This one I just finished the marking. This guy, this one you are not getting the marks properly. Anyway, so but this one is contributing only how much 5%, right? So it should be okay for you. Regarding the class test, still I'm checking the marks, but not allowed to disclose the marks here now. But I can just show you some section 3. Some marks are here. Okay, still I'm checking, so maybe it's still good condition, but some students got poor, but not finished yet. Section 4, still this student, are you in my section? Izuddin, Lutfi, because I found your name in 2 different sections. I don't know why. Okay, later on I will clarify because now is the class time. So this overall is still okay, above 10. A few students less than 10. That should be okay. I'm not sure about the marking for question 1 and question 2. This one, Dr. Fuad will consider. Okay. Okay. So I go to the main theme. So today I'm going to start the numerical integration, but you can see that in the e-learning I already uploaded 3 videos, 3 lectures. Okay. So that lectures are actually very detailed. But here, same as before, so I will try to explain briefly what we are going to learn in this course, in this numerical integration. And this week will be no quiz. So the quiz will be next week, okay, starting from the next week. And I will also give one project too. So, but before that, you have to submit the project one. For the project one, you have to use the MATLAB. Okay. Some students request to use different software, but I just suggest to use MATLAB. But if you not willing, if you have serious obligation, you don't have the softwares, so then I can consider. Okay. But if you can manage, try to be Unite, or maybe if your friends is using MATLAB, and actually we are requested to use MATLAB for this course, so that's why I suggest to use MATLAB. But if you have serious obligation, you have a very big problem, you cannot manage the software now is under CMCO, so that will be different case. But if you can manage, should be okay. When you prepare this individual project, so you have to solve the 4 problems, right? How many problems I gave, you have to solve the problems with the MATLAB. You have to include the code. You have to, if you can plot something, you can plot if it is necessary. And also you need to write the one introduction, one discussion, one conclusion. So this is one report, but that has 4 parts. So when you discuss, you have to discuss the 4 individual problems. When you write the introduction, you have to write the introduction on the 4 different, the topics on the differential equation. But what kind of problem I set, so you have to also discuss those kinds of problems based on that, based on your understanding. Okay, so these things you can include. I don't think it's a tough job because it's individual project, but you can actually discuss with your friends, should be okay. But you have to submit your project individually. So let's try to go to the main theme. So this is the numerical integration. So I hope you already know the numerical differentiation, where we try to solve the differential equations using algebraic equation, right? We use the forward difference technique, we have the backward difference techniques, we have the central difference techniques. So these are very, very easy. So the equations will be given, just you need to simplify it, substitute the value and solve the problems. That's an easy job. In case of numerical integration, so this is also very easy. Okay, not that much difficult. It's very easy. So for the details, please refer to my online lecture. So mainly we have 2 different types of method. Okay, one is Newton Cotes method, or quadrature. We say is quadrature. Sometimes we call it Newton Cotes method. Should be okay. And another one is we have the Gauss-Legendre formula, or we can say that Gauss quadrature. Okay, so we can have these 2 methods. Inside this one, we have very, very simple rule like rectangular rule, we have trapezoidal rule, we have Simpson first rule, we have Simpson second rule. So Simpson first rule is also known as Simpson 1/3 rule, and Simpson second rule is also known as Simpson 3/8 rule. Okay, so these are the rules, and Gauss-Legendre formula is a little bit different than these formulas. Okay, so we have a special types of formula like this. Okay, so next is, this is the ideal form of representing the numerical integration. So you already know that you need to integrate this function from a to b, and the function that you need to integrate is f of x, right? We have called this lower limit, we have called this upper limit, and we can integrate this function if the function f of x is continuous. So for an example, if of f of x like this, and you want to integrate it, from a to b. So this one is a, this one is b. So in between a to b, this function, this equation, or the f of x should be continuous. So this is the first condition to integrate. Okay, if the function is discontinuous, it means, for an example, you have like this, and you have like this. Then you want to integrate from here to here. So normally, if you want to integrate like this from here A to B, and your function is discontinuous at this point, so you cannot use the analytical way of integration. But in case of numerical integration, we can do it. Okay. But maybe remember that. So in that case, we need to split it. We need to split like the area under this one and then area under this one. So then we add these two. So we have to remember that numerical integration means area under curve. So if you have any types of curve and you want to integrate from here to here, so the value of the integration will be this one. If you consider this area under the curve from the lower limit to upper limit, that will be your area and that will be your integrated value from here to here. That is, the integration is nothing but area under the curve. Now, the things are when you can apply the numerical integration and why we need it. So if your function is very complicated, you cannot integrate. So what we do, we try to integrate it using very approximate way. It means a numerical integration. So as I said, that numerical methods are approximated method, so it's not the accurate method, so you no need to integrate it using some analytical formulas. Okay, so what we can do, we can apply the numerical techniques. And sometimes you don't know the function. It's actually the requirement is the same as for differential equation. If the function is complicated, you cannot differentiate, you use a numerical differentiation. So here is the same. If your function is complicated, you cannot solve, so you use the numerical integration. If the function is not known, okay, and if the tabular values are given, you can also use numerical integration because you don't know the relationship directly. If the limits are maybe infinite, if you have some 0 to infinity, you cannot integrate analytically, but you can integrate numerically by approximating the values. And if the function is discontinuities, if you have discontinuous function, this one also we can perform the integration using numerical method. Okay, so these are some requirements or the basic need why we need the numerical integration technique. Remember that numerical integration is also known as numerical quadrature. So don't be afraid like numerical quadrature. So this is the same meaning of this. Next thing is, as I said, that the integration is actually area under the curve. So if you have f of x, you want to integrate from a to b. So the integrated value will be these shaded areas. Okay. And so this is one typical type of problem. So this one is the axial displacement, okay, du. So there is a pipe where the cross section A, okay, is a function of x. It means you can see that there is not uniform cross section. With the change of the x, A is also changing, and the value of E in this Young modulus of elasticity, in this case, also a function of x. Okay, so because the cross section is changing, E should be changed. So that's the two equations. It means that the relationship of A and E with respect to x are given. So it means like if you draw any particular cross section based on the value of x, you can calculate the value of A and E for that particular station or section. So the displacement change with respect to the x is given by P by EA, where E and A is a function of x and P is a pressure, that is the length is given 10 inch. Okay, so you have to find out axial displacement. It means you need to find out the value of u. So how you find out the value of u? So u should be integration of E EA dx, right? So you need to integrate this actually. So in order to find out the value of u, you need to integrate this one from where? From 0 to L. Okay, so that's the way. So you can integrate it directly. So you have put the value of E and A as a function of x, then you can integrate in analytical way. But another way is numerical solution. So how you can do it? So that's, we have different formulas. So that now we will focus on how we can solve it. Remember that when we use the numerical integration, what we consider, we need to integrate from here to here. Okay, A and B. So when we consider a rectangular formula, we consider is a rectangle like this, and we try to find out the area under this. So it means this, if this is H, this is the sorry, this is the H. Maybe we call this H here. Maybe this is B. So the area will be BH, right? So this is the rectangular formula, rectangular rule for numerical integration. So that's very easy, and we never use these things in the higher education or when we are investigating some sophisticated problem. These contains a lot of error. In short, okay, so this is a rectangular formula, rectangular rule. How about the trapezoidal rule? In case of trapezoid, so if you are integrating from here to here, A and B, okay, what we consider, we connect these two lines. Sorry, we connect these two lines, and we try to use the formula using the trapezoid. So trapezoid will be, what is the area of the trapezoid? Half of A plus B multiplied by H. For an example, okay, so this one is confusing here. So I just write, I don't write this one. So for an example, this is considered f of A. This one is f of B. I don't have a space, so I write here. So area will be half of H. H in this case, B minus A. Okay, B minus A multiplied by your f of A plus f of B. So that is the area of the trapezoid. If you see my video lecture, you will understand. So what we do, we try to consider the area from A to B. We approximate the area by considering a trapezoid, and we try to use the formula for calculating the area of the trapezoid, that is half of H multiplied by A plus B. So you can try to get the area for trapezoid. And for rectangle, you already know that B multiplied by H, right? So the height multiplied by breadth. So one difficulty is here, you can see we have different height, this one and this one. So which height we should consider? When we consider B, which one we should consider, this one or this one? So that's another problem, okay? So it's found that if you consider this line, it means the starting line instead of the second line, we actually, what you see can understand that if I consider the height here, so we are actually under predicting because the area is here, right? But we are considering less area than the actual area. On the other hand, if you understand from here, if I consider this line, green line, then your B will be like this, right? So you are actually over predicting the area. So your actual area is under the red line, but you are considering the area under the green line. So you are over predicting. So what we do here in case of rectangular rule, we try to consider the average. Okay? So when we consider the height, that is the B value in this case, we try to consider this plus this divided by 2. So we try to consider the height that will be the average value of left arm and right arm. So you the best solution. So these things are discussed in my video, okay? And in case of trapezoid, we always use a trapezoid like this. And one thing that when we consider the numerical integration, we need to consider, to increase the efficiency or to decrease the error, we need to consider the strips. In this case, for an example, your f of x is here, and you integrate from A to B, just considering by like one trapezoid, you are considering how many trapezoid? One trapezoid. So this one, you will get the solution, but that will contain a large error because your H is very large. Hold on. So because your H is very large, in this case, B minus A. So what we consider normally, we try to use a strip theory. So we try to divide the total area into several number of trapezoid, and we try to sum up all the area of the trapezoid. Okay. Instead of considering one trapezoid, we can divide the area into number of trapezoid. So we call this strips. One trapezoid means one strip. So normally it's said like n is equal to 1. Solve the problem using a rectangular rule or trapezoidal rule when n is equal to 1. N is equal to 1 means number of strip is 2. And if they consider n is equal to 2, so you have to consider number of strips should be 2. Okay, so they consider n is equal to 3, then you need to consider the number of strips should be 3. So when you consider the number of strips more than 1 in case of rectangular rule and trapezoidal rule, we call this composite rule, composite rectangular rule, composite trapezoidal rule, because we are considering more than one trapezoid or rectangle. in the solution. And then we try to sum up the area of each strip. So for an example, this one, we try to get the area, and again we try to get the area for this triangle. So this plus this should be the total area, that is the total result. So we call these trapezoidal composite rules. Okay, so this is a rectangular and trapezoidal rule. So here you can see all the details. So I'm giving you some rough idea. Okay, so these are the two rules, but remember that these two rules actually give a lot of error. Okay, so even though it gives a lot of error, but it's a good practice to get the idea of the total. I mean the integrated value. I mean the approximated value for your integration. So these are the basic things. Okay, so as I said, like if you consider the left side or right side, so we are under predicting and over predicting. So what we do, we try to consider the average values. So I'm not going in details for this part. So I already explained this one in my video. So I go to the problem directly. Okay, so I try to solve on problems. So these are explaining the when we are considering the average values. Okay, when we consider the rectangular rule. And one more thing that you can see here. The total area instead of A to B, what we are going to have here, we are considering strips. Okay, so how many strips we have? 1, 2, 3, 4, 5, 6. In this case, we have 6 strips. Okay, and for each strip, so you know that you need to consider the strip with H. In this case, H will be from here to here, and H is uniformly distributed. H is same for all. So how you gonna find the H? H will be B minus A divided by N. N is number of strips. So this one I already explained in my video. So if you know this one, if it is 5 or whatever it is, and you know how many strips you have, so if you divide it by that value, you will get that B. I mean that H, a strip. And H is same for all. Okay, H is same for all. So if you have these kinds of things, so we can make one table. In my video, you will see that I always request to make the table form. That is very easy and very convenient to solve. So instead of using some direct method, I mean using the solving the problem in one line, you just make the what can I say, a table. So in my video also I showed this the same things. Okay. Okay, for an example, the rectangular rule. So what are the values you can find? You can find the value of x. Okay, then the value of y. Y means f of x. Okay, and then you have product. That's all, finish. So you when you have this like this from here to here, you want to integrate. Suppose this one is difficult for me to draw a straight line. Sorry, just try to understand. So for an example, this is A, this is B, and this one you need to find out the values. Okay, what will be the value of this? A plus H, right? This one A plus 2H. You already know the H value because you know A and B, and you know how many stripes we have. This one A plus 3H. So for simplicity, what I consider here, this one is x0, maybe x1, x2, x3, and x4. So what you will do, you just write the value of x0, x1, x2, x3, x4, and you need to find out the corresponding values for this one, for this one, for this one, this one, and this one. So write down the value for this. That is f of x0. Okay, f of x1, like this. I hope you understand. And this is rectangular rule, so we just multiply this one, this, and we will consider the summation. This will be your result, area. Okay, that is a very simple way using the rectangular rule. How about the trapezoid? If you have any objections, you are not understanding, let me know. Okay. But remember that all the things are well explained in the video, so you have to watch the video. So in case of trapezoidal rule, so as I said here, same thing, but we are considering, instead of rectangle, we are considering trapezoid. And one more thing I forgot to mention here. So here I consider this line, right? But normally, in order to get the less error, you need to consider the average. I forgot to mention here. So for this strip should be this plus this divided by h. Sorry, this plus this divided by 2, average value. So you have to consider the average value here. For this average, you have to use this one. For this rectangle, you have to use this average. And for this rectangle, you have to use this average. So my explanation is bit not correct. So 1, 2, 3, 4. So this x naught. So in this case, we consider, maybe I explain in different ways. Okay, I re-explain this one because I explained it for the trapezoidal rule. Okay, this one should be, please correct it. Okay, because we are considering rectangle. So normally for the rectangle, we rarely use these kinds of thing. So in this case, you have h. In this case, should be this minus this. So in this case, you will be have h. So 1, 2, 3, 4. So as I said, we normally rarely use this because these are h, right? So the way that I explain here, this one is actually for trapezoidal. I'm sorry for that. And this one will be this plus this divided by 2. This is the average value for this. So just consider the average. Okay. So average 1, average 2, average 3, and average 4. Anyway, then you have the product and then sum up. It's just calculating the area for this one, this one, this one, and this one, then sum up. So I'll go to the trapezoidal rule better. 1 minute. Okay, so in case of trapezoidal rule, we have this ordinate. So we can get the area for one trapezoid, half of f of f naught plus f1 divided by h. So if I consider I1, how to write I1? I1 will be half of this. For example, this is x naught, this is x1. Okay, so maybe this is x naught, x1, x2, x3, and x4. So that should be actually h. I consider h. Okay, should be h because h should be x1 minus x naught will be h, x2 minus x1 should be h. So this is h multiplied by f naught plus f1. That will the area for I1. So similar way, area for this one will be half of h, this plus f1 plus f2. So now if you have I1, I2, I3, and you want to sum up what you will get. Okay, I just show you one simple example to make the general formula. Okay, that will be half of h, then this will be f1 plus f2, right? So I will be, let's consider I have only 2 strips, so I will be I1 plus I2. So if you sum up, what you will get? You will get half of h, then f naught plus 2f1 plus f2. So this is your total area. One moment. Okay, so this is the total area. So in short, the total area will be half of h. If you start from here, f naught, and all the intermediate line will be shared between two trapezoids. So the formula will be 2 multiplied by f naught, f1, sorry. So this one, if you have this one is also shared between this and this. So this one also need to be multiplied by 2. So the multiplier is, in this case, if you consider these two trapezoids should be 1, 2, 1. Multiplier means I am considering here multiply by the function. So this one is 1, this is 2, and this is 1. So if you have 5 or 6, so what will be your multiplier? Multiplier will be 1, 2, 2, 2, and 1. So when you consider the first and the last one should be, multiplier will be 1. All the intermediate ordinates you need to multiply by 2. Okay, so now let's consider the table form. So for an example, so I just draw here. So these are your function. For an example, x0, x1, x2, x3, x4, x5. Let's see. We are trying to use the composite trapezoidal rule. So this should be, of course, f0, f1. You know these values by using from the table or by using the relationship. So f4, f5. Okay. So now you have the multiplier. In this case, you need to consider the multiplier. We call this multiplier. So when you consider the multiplier, you remember the first and the last is 1, and intermediate will be 2, 2, 2. Then you have the product. Okay, so you just consider product means in this case, which one? F multiplied by multiplier. So in this case, you can use the heading like something like you value of x and then f, then you have multiplier. Okay, so this is the value of all x and this is the value of for function. So this product is actually this multiplied by this. So after you multiply all the f with this multiplier, it means this one should be f1, 2f2, right, 2f3, 2f4, and then we have f5. Then you do the summation product. So your area will be, area or integration will be half of h multiplied by product, this one. So why we have half of h? You can see here in the main formula, here. So in the main formula, we have half of h. So we in the table, we just consider the inside term. So when you get the product, so we have the product and the sum up. So then we have multiplied by half of h. So this one is common, right? So that's why I multiplied by half of h later on. So this is the summation of the product and then you multiply by half of h. This one I better explain in the video. So please rewatch again, so it will be clarify everything. So this way we can solve the problem using trapezoidal rule. So remember that it can be given like you might have the relationship like this, f and f is like this in tabular form, or it said that f of x could be maybe x squared. Okay, and you integrate the x from maybe 1 to 4 and consider n is equal to 4. So it means you need to integrate from 1 to 4, but you need to consider n is equal to 4 means you need to consider 4 streets. It means 1, 2, 3, 4. So this one should be your 1. This one is actually 4. Okay, so then what would be the intermediate values? You need to find it out. So maybe 4 minus 1 divided by 4, that should be different. Maybe it's becoming fraction. So I consider n is equal to 3. So your h will be 4 minus 1 divided by 3. So that should be 2. That should be 3. There will be maybe the section is only three trapezoid. So in case of 3 trapezoid, so in this case 1, 2, 3. So this is your 4. We are not considering this one. So this is 2 and 3. So 1, 2, 3. This is the x value is 1. X0 will be 2. X2 will be 3. And x3 will be, x0 will be 1. X1 will be 2. X2 will be 3. And x3 will be 4. And the functional value maybe just multiply, square it, right? The relationship is given. So that's how we solve. So for an example, evaluate the integral using trapezoidal quadratic. So your h is given 0.1. So in this case, your h is given 0.1. You need to integrate from 1 to 1.6. So you remember that. So your h is 1, right? So your starting value for x in this case is 1, then 1.1, 1.2, 1.3, 1.4, 1.5, 1.6. Your function, just put the value of x is equal to 1. So e to the power, this is your function, right? E to the power 1 to the power 0, 1 square, so e to the power 1. So e to the power 1.1 square, e to the power 1.2 square, e to the power 1.3 square. You write the values. Then you use the multiplier, in this case Simpson trapezoidal rule. So multiplier will be the first and the last will be 1, and all the inside one will be, multiplier will be 2, 2, 2. Get the product, sum of the product, and your result will be half of h, in this case 0.1, multiplied by summation of the product. So that will be your answer. You try to solve it by yourself and give me the feedback using trapezoidal rule, and also try to solve it analytically using your calculator and try to get the error. Determine this one. So here the function is very big. The relationship is given. It should be okay. Is a polynomial. So your a and b is given using trapezoidal quadrature with different intervals. So they ask you to try different intervals. It means the h you can consider 0.1. You can consider how much? You can consider also 1. So 0, 1, 1.5, or you can consider 0.5. Sorry. So 0.51, 1.5. You can also consider 0.1. So 0.1, 0.2, 0.3, 0.4, like this. You need to continue until 1.5. And then if you compare, you will see that when you consider the h is smaller, in this case, so when your h is smaller, you will have less error. That's proof, okay? So same like before what I said in case of differentiation, when you consider the small strip width, your result will be improved. So you can check back all the things. Simpson first rule. Simpson first rule, no need to consider the derivation here. Simpson first rule is also known as 1-for-1 rule. So what is the basic thing here? Basic difference is when you consider the integration a to b, we actually consider, we consider an additional strip here. That will be your midpoint, okay? So that will be your a plus h. This is h. And how we consider h? H in this case, b minus a divided by 2, because your strip is n is 2. Okay, so in this case, h is b minus a divided by 2. It means when you integrate from a to b, you need to consider the midpoint, and you need to consider 3 ordinates. So you, in order to apply the Simpson first rule, you need to have odd number of ordinates. We call this ordinates. The vertical line, we call this ordinates. We call it ordinates, okay? So if your ordinate is 3, 5, 7, 9, 11, 13, then you can use the Simpson first rule or Simpson 1/3 rule. If your ordinate is 2, 4, you cannot use this rule. You cannot use this rule, okay? Remember that. So, but rectangular trapezoidal you can use anytime. But Simpson first rule, if you want to use this rule, you must have odd number of ordinates. This one I also mentioned in my video. It means you need to find out how many ordinates you have. In this case, you have 1, 2, 3, minimum 3. So that's why when we need to integrate from a to b, you must have a middle ordinate, and that h at a distance of h. H is, this is h, this one is also h. In this case, h should be b minus a divided by 2 because your n is 2. We have 2 strips, okay? Then what we consider, we try to consider a line that is polynomial. Polynomial, okay? And the polynomial line is this one. We are not considering the straight line like in case of rectangle and trapezoidal. So we are considering polynomial. So that's why it gives you better result. In this case, we are considering second order polynomial. Okay? In case of Simpson third rule, 3/8 rule or Simpson second rule, we consider second order polynomial. So that will be more better. So I'm not going to prove these things. This one I already explained in my video. And when you solve the problem, your integration will be this one. So for example, this is x0, this is x1, This is x2. This is a minimum, right? 3 ordinates. So you already know f of f0, f1, f2. So these are the ordinates. So you want to find out the area under this from x0 to x2. So your area will be, so this is the formula, 1/3 h. You need to remember this one. 1/3. That's why we call this 1/3 formula. We have the multiplier is 1/3 h. H is this one. In this case, h is b minus a divided by 2, right? So if you don't want to make the things complicated, you just consider that h should be from here to here, and this h should be from here to here, and both h should be same. So then because the x1 will be x2 minus x0 divided by 2 is the midpoint of x0 and x2. And then you need to consider the multiplier. You remember in case of trapezoidal rule, what I say, for the first and the last should be 1, and all the intermediate should be 2, 2, 2, 2, like that. So in this case, we are considering single, is not composite rule. A single rule should be at least 3. So we will have f0 4 f1 plus f2. So we have the multiplier is 1, 4, 1. The Simpson 1/3 rule is also known as 1, 4, 1 rule. Say number of strips or question. Yeah, number of strips in the question will be given. If it is not given, you can choose the minimum one. So normally we give that the formula Simpson first rule for n is equal to 40, maybe 4, 6 or 2 should be given. Okay, so next is have the f0, f1, and f2, right? Can you mute? Okay. So next is what I said. We have the multiplier is 1, 4, 1 because we don't have enough time. So 1, 4, 1 rule, right? We call this 1, 4, 1 rule because the multiplier is 1, 4, 1 rule. So this one is even. They say that this one is for considering the number of strips, but I'm considering number of ordinate. Remember that. Okay. So odd number of ordinate. Odd number ordinates. Ordinates means vertical lines. So don't focus on here, okay? So you will be confused then. So odd number of ordinates. So now what we will do is very simple. Now again we can prepare Simpson rule. Table for Simpson rule. Remember that for Simpson first rule or 1/3 rule or 1, 4, 1 rule, your n minimum n is 2, right? Because you understand that we have to divide it at the middle part. So minimum n is 2. So if you consider n is equal to 2, so that means that you have to use a simple formula. But how about if they use n is equal to 4? If they say n is equal to 4, it means that what? So it means that if you need to integrate from here a to b, so you need to have 4 strips. 1, 2, 3, and 4, right? 1, 2, 3, 4. So this one should be, let's consider this is x0, x1, x2, x3, x4. So x0 will be a, x4 will be b, x1 will be x0 plus h. So you need to know that what is the h here. So how to get the h? H should be b minus a divided by n. How about the n? N is in this case 4. Or you can just divide it by yourself. You need to find, if your extreme ends are given, you are considering 4 strips. So what is the interval? That is the basic thing. Okay, you can find it out by yourself. Or the formula is b minus a divided by 4, or number of n. So next, you need to find out how many stations you have. We don't have enough time. Okay, I will try to faster. So how many stations we have? Ordinates or stations? 1, 2, 3, 4, 5. Odd number. So it's okay. It's matching, right? So we just, like before, we need to prepare the table. We need to prepare the table. So this is x, this is f. We need to consider Simpson multiplier, Sm, and we need to have product. Okay. So what we have? We have x0, x1, x2, x3, and x4. So we have f0, f1, f2, f3, and f4. Then we have multiplier. Now you have the term. So let's consider 3 by 3 because you need minimum 3, right? So your multiplier will be 1, 4, 1. Okay, done. Next, the F2 is again the common with the another term, right? So in this case, we are considering this one, and again we are considering this one, but this one is the junction point or the connecting points. So this is common, right? So here you need to connect it. We cannot be discontinuous. So again we need to write 1, 4, 1. So how much you have? 1, 4. This one should be 2, 4, 1. So that is the way. So you need to write 1 for 1, 1 for 1, 1 for 1, 1 for 1, like this. Combination of 3 ordinates, and then sum up. So you will have 1, 4, 2, 4, 1. So then if you have the product will be, you know, that F multiplied by a Simpson multiplier. You just write down the product. Okay. And then your answer will be, you sum up. Sorry. So after that, your answer will be, you need to sum up the thing here. Okay, hold on. You need to sum up, and after that your integration will be, remember, 1/3 h summation of this product. 1/3 h, you need to multiply it. So h will be here b minus a divided by 4. So like this way we can have n is equal to 2, 4, 6, 8, 10. It could be given. Then you have to make your table in this way, and you need to shuffle the Simpson multiplier. Okay, so that's the thing. So try to solve some problems and try to watch the video. I will again explain something about the Simpson 3/8 rule in my next class. So there you will see that in this case, Simpson 3/8 rule, we need to consider 3n plus 1, 3n plus 1 number of ordinates. So if you n is equal to 1, so that should be 4. So if it is equal to 2, 7, 10, right? So for these kinds of ordinates, we can apply the Simpson 3/8 rule. So the formula is, we can also call this 3-1-3-3-1 rule, because the formula is like this: 3/8h, then we have f0 plus 3f2 plus 3f3 plus f4. So we must have at least 4, right? 4 ordinates. You can see at least 4. So 1, 2, 3, 4. At least you need to have 4 ordinates. Okay, so I will talk about in details later on. But before starting my next class, I hope you all finish my videos. Okay, at least Gauss method. Which one? Gauss method. Gauss method. Which one? Newton's first. You are talking about the class test or this lecture? Ning, you are talking about the class test in Gauss method, Gauss quadrature. Oh. This one, Gauss quadrature. Oh, this one I will explain next week. No problem. Or I will continue to explain. I will explain all the things. Don't worry. Okay. So this one, I know maybe you will have problem. I will re-explain in the class. Okay. So that's the end of the today's class. So yeah, sure. I will share the attendance. So far I have explained the rectangular trapezoidal Simpson first rule, Simpson 3/8 rule. Also very simple. If you can see the video, should be okay. But Gauss quadrature, I will explain again. Okay, I will share the attendance. Okay, hold on. That's good. If you already watched the videos, that's good.